Hello, everyone, and welcome to Handmade Hero, the show that we code a complete game. I should say, where we code a complete game live on Twitch. No engines, no libraries. It's just us. And one of the things about it just being us, it means that we have to debug all our code ourselves, of course. And one of the things about debugging code is that it can be really difficult sometimes to debug difficult bugs if you don't have some tools at your disposals. Obviously, one of them is a debugger, but another one that's very common in game development is actual debug tools that you write yourself that are built into the game that help you narrow down the spaces where bugs could be, or help you find the bugs in the first place. And that is what we are doing right now on Handmade Hero. We're taking a look at some things that we can build into our code base that will allow us to find bugs more effectively, and allow us to sort of, if you will, like percolate bugs to the surface too, in cases where bugs may be hiding or lurking around. So we're trying to make bugs more visible, and we're trying to make them easier to find. We just got started on this yesterday. I gave a little bit of an overview, and then we kind of started programming, but we haven't gotten very far, so today will really be our first full day of coding on this, and we have plenty of stuff to do, so I think we should just go ahead and get right into it. Now, today is day 177, so if you pre-order the game on handmadehero.org, what you want to do is download unpack day 176's source code into a directory, and you want to start working with that because here on day 177, that's what I'm starting with. So if you want to follow along at home, that's the way to do it. Now, if you remember where we left off yesterday, I had just started making a handmade debug.h, which I just wanted to make a separate file we could start putting debug stuff in because we're going to have a lot of it. And I'd like to keep, as much as possible, the debug code isolated from the main code so that we can kind of see what's debug and what's not and have easier ways to turn it on and all that sorts of stuff. Because we've got a bunch of work that we have to do there. So I'm just going to start dumping it in this file so that I can kind of keep it separate. Now, what we did here is we started to kind of work on our debug cycle counters, and that's because we had already done them. And so I thought the first thing that might be fun to do with the debug code and getting that sort of stuff up and running was to sort of make these debug counters into something that was a little more usable as an exercise. And so that's what I'm in the middle of doing. Okay. So we pretty much finished that very simple step of just making a macro that instead of having to do a begin and an end for every time block that you might want to do, you could actually do it so that you just have a structure which has a constructor and a destructor, which will make it so that the compiler will automatically insert the constructor and the destructor into the block, and then you can get a start and an end that happen automatically, right? But that still doesn't quite get me, in fact, it's not really even getting me anywhere close, to be honest with you, to the level of ease of use that I actually want in my timing system. Because remember, as we talked about, there's a bunch of things that we want to have happen here in terms of ease of use, and one of the biggest ones is whenever we have one of these like a time block thing, I want it to be almost free, as free as possible to just drop one of these in anywhere. But that is not the case, right? So why is that not the case? Well, first of all, so we replaced the begin and end at the front and end of this thing. We replaced that with time blocks, so that took care of like some of that extra typing of having to go down to the bottom of the block and do it. That's fine, right? But suppose I want to time a new function. So I want to time, say, draw bitmap, right? I put something in here, I say draw bitmap. As far as I'm concerned, that's really all I should have had to do, right? I should be able to just go ahead and do it that way, and I just hit compile, and now I've got a new time block. But you'll notice with the system that we constructed earlier on, we don't have that at all, right? It's going to give us an error, and the reason it's going to give us an error is because that draw bitmap needs to correspond to some kind of an ID that's been sort of written up in here, right? And so it forces the programmer, in the middle of thinking about whatever they're trying to do, it forces the programmer to stop what they were doing and just to use the debugging system, come out and remember how this works, add a new debug counter to it, right? It's just not, that's not the mental flow that I want. I want to be able to just spam this in here and be done, right? And you remember we have sort of this with asserts, right? I can just say assert buffer is not equal to 0 or something. I can just type that in, and now I've just added some nice debug code that I never have to worry about again. It just works, it does what I want, and I didn't have to go think about any code structure or jump to another file or anything. So that's where we want our block timing to end up, I think. That's really more where I'd like to see it be. So how do we get there? Okay. Well, there's a couple problems that we have. There's a couple things that we need to keep in mind. The first one is that this kind of a thing, like with timing a block, is somewhat performance critical. The whole point of timing a block, right? The only reason that we're going to time a block is because we want to know the performance of that part of the code. So the last thing that we want to do when we go to time a block is insert a lot of unpredictable overhead or expense into that operation. Because the more expense we insert into that operation, the less we will be able to use it, first of all, right? If it was really expensive, that would limit the number of them we could even do. So that's not good. But even more importantly, the more heavyweight the operation that the block timing has to do, the more it affects the performance of the code that it is trying to time. So if I'm trying to look at how draw bitmap performs, and I do something in time block that goes and walks a bunch of data structures and copies strings around and does who knows what, I'm going to be in a situation where the state of the cache on entry to draw bitmap could be significantly affected by my attempts to profile it. So it's worth noting here that I'm not just trying to make this easy to use, I'm also trying to make it very efficient so that to the extent reasonably possible, it will not unduly modify the state of the computer as it rolls through. Because the more I can avoid sort of Heisenberging it, the more accurate and useful this timing information will be. Right? Okay. So, this is going to require some work on our part. And it's some relatively major work that I've been putting off for a while. I hinted at it at the very beginning of Handmade Hero, but it's going to start, you'll start to see why some of these things take place, and we'll kind of show how to deal with some of them and all that sort of stuff. But it's a good thing, so don't, relax, don't worry too much about it. This is the kind of thing that I like to do in programming all the time, and changes that are major, in my opinion, should not be things that scare you. As long as you are confident and you keep a good eye on what you're doing, it's not really too much of a problem. But to start with, we're not really going to go for the major change part yet. We're going to go for the minor change, and we're going to kind of work our way up to it. So first things first, how do we get rid of our IDs? Well, it turns out that in C, there is a relatively easy way that we can get some information about where this time block is in such a way that we do not need to introduce some additional enumerant for telling where it is, right? And those are the preprocessor directives that we've already kind of seen, right? Well, actually, you know what? Now that I think about it, maybe we've never seen them. Have we ever used these? Maybe we haven't. All right, I guess this is the first time. So that's totally fine. Let's go ahead and show what they are. So if I wanted to, at any point in C, the preprocessor, right, the thing that does like handles pound include and pound define, that thing, right? If I want to, at any point in a C program, I can go into, and I'll put this right at the beginning so we can see it, I can go into game update and render, or anywhere else for that matter, and I can use a set of directives, and here they are, right? This is just a couple of them. File, function, line. These directives will actually expand to exactly what they say. If I want to, I can get the file name of the file that's currently being compiled just by using that directive. I can get the function name, right, by using that. And I can get an actual, integer line number by doing that, right? Now, sometimes there's some const string nonsense that happens there. So sometimes you have to cast them. And that's because people who I, would slap around a bit if I got my hands on them think that forcing people to use const is a good idea. We'll have words. We'll take them out back behind the shed, and it's fine. But you can always cast that stuff away, so it doesn't pose up too much of a problem. But I'm saying some compilers like LLVM will give you warnings there, and you have to cast them. So we may have to deal with that when we're going to other platforms. But for the moment, on Windows, it's still relatively sane. So if I go ahead now and I make a breakpoint at game update and render, and I run, now you can see that when I step in here, those variables will have the pieces of information that I asked for set, right? So what the compiler is doing here is the compiler is actually going to embed these strings into our code when it compiles it, right? So it's not like at this point in the code it's going and asking some oracle what the file name is or anything. All it's doing is on the compile pass, it's actually seeing that this existed. It's seeing, like, say, what function it is or what file it is, and it's actually adding to the string table that string and pointing this at that piece of the data segment of the executable, right? So it's just adding basically constants. But those constants are automatically defined by the compiler, so we don't have to worry about doing it ourselves or making them out of date. We don't have to go, oh, it's line 843 and put 843 there and then worry that when we add lines to begin the file, that becomes wrong, right? So it's pretty nice. So the line number 843, that is what it is, right? The function name is game update and render, which it is. That's great. We have the file name, which is also which is there, 841. And there's one other, which to be honest with you, I don't super remember whether it's actually allowed in all C compilers. I think it probably is at this point. And so I'm going to kind of show you, I'm going to show it to you, and I think at this point it's probably safe for us to use. I don't know if we'll have to use it, but I just want you to be aware of it, because it can be kind of useful for certain situations that we may find ourselves in. I can't really predict if we will or not, but I'm just going to go ahead and show you. So assuming that MSVC supports this guy, which I'm pretty sure he does, or she, I don't know the gender of Visual Studio. Probably an it would be my guess. So I'm going to run through here, and you can kind of see that each one of these guys now takes on a value that is the number of times that underscore underscore counter has actually appeared in this file. Now, there really isn't too much of a point in doing this other than the fact that, in theory, if you were trying to use something like a line number to disambiguate something in a macro, if two of those appeared on the same line, they would have the same number. So counter, especially when we're dealing with debug situations, counter is a good thing to know is available, because if you find yourself in a situation where multiple things on the same line want to be able to be distinguished by some kind of a preprocessor number, you've got a way that you can reliably do that, and so that can be kind of handy, right? So those are some things that just to be aware of, because now we're going to start using those to help us do some things automatically. And again, this is not typically something that you really need to use too much in your actual production shipping C++ code. Sometimes you do. But it is something that you will absolutely use all the time in the debug augmentation of that C++ code. And here is a perfect example of where we're going to do that. So what I'd like to do now is, if I go ahead and take this timed block here, right, and I have that draw bitmap, what I would like to do is be able to, and let's just, go hog wild here. Let's just say we want, we want everything. Let's say we can just go, okay, we don't want to say anything. We just want to say timed block, and the block is timed. I don't want to know anything else about it. I don't care. I just want you to time that block, and I want you to display it for me in some way later on that's going to let me know what block was timed so that I can go find it again if I'm curious, right? That's what I want. Okay. So in order to do that, we see this timed block. We know that we're going to instantiate one of these, so this part stays basically the same, right? But then this part is going to be a little more complicated. We don't have any way of using an ID here or anything, really, right, we don't have any way of disambiguating this because the person hasn't passed in an ID. But that is, again, the perfect place where we could go ahead and stick, say, the line number in. So now we know that even if someone has timed the same block multiple times for some reason, we know that this timed block will never name conflict with itself, right? So that's a perfect example of a way we could use line to disambiguate. So now we can just do time block. We don't have to pass in anything. Okay, that's step one. Step two is, okay, we can't pass debug cycle counter, right? Because debug cycle counter is this enum sort of thing. So we have to switch to using something, again, that isn't going to be, isn't going to be something we have to predefine. But in addition to that, we also need some way of identifying where it is, right? Because since we're not going to use any kind of predefined values anymore, we're not going to be able to know when we see the results of this timing, we're not going to be able to know where the actual time block was in the code. So we see something comes up and it's like, hey, it took 4 milliseconds. Oh, well, maybe we should go optimize that. Too bad I don't know where it is. It just says debug counter 4 or something, right? Well, that's no good. So clearly what we'd like to do here is pass some information that we can use to both disambiguate which timer this is in our debug code, but also be able to determine where it is when we actually then go to display it to the user, right? And so again, we already kind of know the stuff because I just showed you what they were. It's pretty trivial for us to say something like this, where now we will be passing all of this useful, very useful information about the location into the actual timed block, so we can accept it here, right? We can get the file name, we can get the line number, and we can get the function name. So we can pass that useful information in, and so not only will that allow us, say, with the file name plus line number, would totally disambiguate it, because we know we're not going to have multiple times, no one's going to write this, right? But even if they did, if we wanted to, we could, if we found ourselves in that situation, we could even go one further, right? So even if they did want to do that for some reason, we don't care, but if you did, you could even go one step further. So that is an easy way to make sure that we can both disambiguate it, because file name plus line number will do that, and then we also have plenty of information, because file name plus line number and function name, which we can just print out as a convenience, so the user doesn't have to look and see, oh, that's what's in that file line number. Oh, it's draw bitmap. Now we know it's draw bitmap, no problem, right? So that's pretty useful. So now you can see that we have enough information to do our jobs, but we don't really have a way of actually doing exactly the same work that we did before. Because in order to do that exact same work, we would have to have some way of mapping a file name and a line number down to an ID, which we don't really have, right? We don't have any way of kind of collapsing that thing. So we now need to start to think about what we're going to do to translate a file name line number into an ID. Now, there's a lot of pretty trivial ways we could do this, right? Anyone who's had Intro to Computer Science or has programmed for a while at all or anything like that knows that we could make something like a map, for example, where we can just search, we could make a binary tree, or even we could just do a brute force search. We could do anything we wanted to try and match up the file name line number pair with other ones of its type. So we could just make a little thing that's going to store our counters. We look to see if the file line number is there. If it is there, we increment it. If it's not, we make a new entry for it, and off we go. Right? So I could just start typing that here. Find find ID from file name line number, right? And then I could pass in the file name and the line number. It could go do that stuff, and then we'd have the ID, right? And then all this stuff would work. Totally fine, right? Everyone's happy, no problem. We all know how to write that. However, not so useful, potentially, if we get in a situation where that's going to do a bunch of actual work. Because now, our timer code, right, is going to be in a situation where it's doing traversals of a binary tree or searching through, some list of memory or something like that to find matches to things. And that's exactly the sort of thing that we really didn't want to have happen. Now, it may be, right, it certainly could potentially be plausible that that is still the best thing to do. And I will tell you why in a second. But I would like to at least mention another method that may be the one that we'd like to try first, because it has definite distinct advantages, certain very distinct advantages. Okay, so the thing that I would like to do here instead is what I'd rather do is just store the file name line number and then not have to ever find it until later when we go to print out this information, right? Because if you imagine something like this, where I've got a timer record, and I can just say something like, okay, let's say I've got a thread index, or something like this. I've got a line number. I've got a char star file name, and a function name, right? Something like this. And then I've got whatever the U64 is. That's the RDTSC value, right? The timestamp. Yeah? So if I do something like this, when I use my timer record, timer record. If I do something like that, then every time through here and here, I could just do a timestamp and just write out one of those structures, right? So all it is, the only pollution that it does is writing that thing out. And it really, you could even, I could imagine doing something absolutely ridiculous here and trying to even do a non-temporal store or something ridiculous like this so that you didn't really pollute the cache at all, potentially, right? So that's one option. The reason I bring that option up is because if you are planning on calling this a reasonable number of times, like if I'm planning on not calling it, say, 1,000,000 times, that might be a good idea. If you are planning on calling it 1,000,000 times, well, now you're adding, several megabytes of write bandwidth to what you're doing, and that could affect your performance as well, right? So it's kind of hard to say one way or the other which one of these things is going to be, the most efficacious. Now, it's worth noting that if you take a look at this, right, you could imagine trimming this down a little bit, potentially. I don't know how much. But you could imagine doing something, well, to be honest, it's going to end up being, you're going to need an 8-byte value for the timestamp. The pointers here, I feel like there's not a whole lot you would be able to do with those, unfortunately. I wish that C++ allowed you to do things that weren't pointers for string tables, because, man, that would help a lot of stuff, because really these could just be pretty much 8-bit values if the compiler were actually, flexible and good. This could have been something as simple as this, basically, right? At least. And so that's literally 128 bits. It's 1 op, right, to write that out. And again, you could do that completely in a way that maybe even bypass the cache if you wanted to be super fancy. So that would be a pretty great thing. Unfortunately, that's not the situation. We're pretty much only going to be able to have these guys like that. And so at that point, this pretty much ends up being a fairly balanced struct. It's just twice as large as what I would have liked, right? So it's 8 bytes, 8 bytes, 8 bytes, 8 bytes, right? So it's basically, 32 bytes, right? So every time through on the time block, you'd do a 32-byte write on the entry and the exit. So it's 64 bytes per timed block written, but that's basically it. So the RTTSC plus the 64 bytes written. That, might be the easiest thing to do. I don't know. I'm just pointing it out. And then you would collate those later on. So I don't know. I don't know offhand. In fact, it's been a long time since I've written a debug system, and I haven't done a lot of testing on modern machines. I don't know which one of these they would prefer. I don't know if they would prefer to have these things collapse before or after the fact. What I do know is certainly when the number of timed blocks gets low enough, you would almost certainly want the log version, but that's about all I could really tell you. Okay. So, I'm going to do the log version, because I think the log version is a little more interesting to me. It also has some nice properties that allow us to do some stuff a little later that is a little bit harder to do in a multi-threading context if you don't do the logged version, but, that's kind of separate. And, well, that's not really true. That may be overstating it a little bit, to say the least. All right. So anyway, this is something that we would like to do. And by the way, it's worth noting that really all of this is just compensation for the fact, again, that C++ is not a particularly good language. And so one thing that it cannot do in a particularly easy way is aggregate this data out. What you would rather do is you'd rather have something that generated effectively exactly what I did here. You would want it to collapse down a set of indices, and those indices correspond to, numbers which are like where in the code do timed blocks occur, right? And you would want to be able to bake that number into the thing. Although, you know what? I'm having a thought. I'm having a thought right now. A thought that I have not had before. And that thought is, because we are doing a single compilation unit, well, we have 2 compilation units technically, but even so. Does that mean we could just use counter to actually do that list collapse? Because it kind of feels like we could. Are you thinking what I'm thinking? I mean, it doesn't say specifically, but you know what? Let's just do a test, because, you know, this is something that you can't... I'm pretty sure counter, since it's a preprocessor directive, if you're normally compiling in the way that most C++ projects are compiled, where you have one file, you know, separate file per class or stuff like that, you can't do this. But if you compile everything as one file, counter actually will expand to a unique number for every place that timed block occurs. So technically speaking, I think we might actually be able to totally cheese out on this and just get around the entire problem by leaning on counter in a way that I'd never thought to do before, because I never really thought about how you write a debug system under the single unit compilation scheme. It's something I've only been doing for the past like 6 or 7 years, and I haven't really done much with new debug code in that time. I'm kind of interested to try that. Let's try that, shall we? Okay. I'm pretty interested. I am legitimately kind of interested in what's about to happen here. I don't really know what's going to happen, but I am legitimately pretty interested. Okay, so let's test this out. So if I have my timed block thing here, so instead we're going to have a thing that's like, okay, it's going to pass the counter as the first thing, or something like that, right? So if I'm passing the counter as the first thing, I guess at that point I would want to do something where I turn, I guess we've got another time block down here somewhere, right? So let's turn that off for a second. Undeclare, oops, yeah, this guy's got to stay in there. Okay. This is very interesting. This is going to be pretty interesting if this works out to be, if this turns out to be good. I'll be pretty interested. Right? Okay. So if I do that, now I guess Handmade render group's the wrong place to do it, because that's actually in the one other compilation unit we have. But what I'm going to do here is I'm going to put one in make sphere diffuse map. Right? And, well, I guess I'll try to do something that I can step into a little bit easier. So we'll put one in debug reset. And then I'm going to go into the asset system, and I'm going to put one in the asset startup. Okay? And these are in totally separate files. I want to see if we end up with the values 0 and 1 for our counters. That's what I'd like to do. So I'm going to just make a breakpoint at the constructor for the timed block. I'm going to step in. I'm going to see what we get passed. Counter is 0 on the first one, and that's for Handmade asset 539, allocate game assets. Okay? Oops. And counter is 1. For handmade.cpp, line number 675, debug reset. Well then. That is pretty darn interesting. That is pretty darned interesting. Well, then I suppose there's only a few things we would need to know in order to make this work pretty much exactly the way we want it to. We only have 2 translation units, right? The 2 translation units are defined in our build.batch file. Here they are, right? We've got This one right here, Handmade optimized. And we've got this one right here, handmade.cpp, right? Those are the only two translation units we have. So at the end of those translation units, we know exactly where they stop, right? Handmade hero.cpp is here. That means that if I were to put counter right there, that would be the number of things that we actually had, the number of debug things that we had. Well, that means debug record, something like this, right? Debug records, brackets counter, and I could call this main debug records, or something like that. That would give me an array that I know has all of the debug records in it that's big enough to hold all of the debug records, right? And furthermore, I could make a second one inside the other translation group, which is the optimized one, right? Where is that? Optimized. Which is here. Draw rectangle quickly. Oh, so I guess, yeah, render group I guess wasn't in there. It's just draw rectangle quickly. So I could make a second one in there, right? Optimized debug records. Now I have two arrays that I know are big enough to hold all of the debug records that I might have with those counters, right? I mean, presumably you can see where this is going. So now, I really don't have to do anything. If I want to be able to map this info in, I pretty much just overwrite it every time. So if I go into Handmade Debug and I want to make this time block thing work, well, the counter tells me exactly where to look it up, right? So I've got something like this, right? And in fact, you can kind of, you can see, I mean, presumably you know exactly what I'm about to do, right? This is kind of, it's almost self-explanatory at this point, exactly what we want to do. So at this point, all we have to do is say, all right, when we compile our optimized, we just do something like define debug prefix equals optimized minus d debug prefix equals main. And now I know which one I am doing, right? Optimized. Because debug prefix, depending on the compilation unit, will actually give me the, will tell me which one of these I'm going to want. And so, in order to access the proper set of debug records, all I would have to do is, I could make this a little bit, I don't know if the forward declaration of this would work exactly. Well, I'll show you where I'm going with this in a second, and you can see, we'll play around with it and see which one will work. Okay, so if I were to say struct debug record, in fact, I probably, can I get that? No, I can't. Let's put struct debug record in here, just leave it like that. So if I wanted to, I don't know if I can pre-declare this like this. I'm not sure if that'll work. I doubt that it will. Yeah. That's fine, because this will get one soon enough. So that's actually totally fine. Let's just make sure that works, though. We'll take it out of here first. And look at it in a second. So it looks like we can pre-declare that just fine. So actually, we're totally good, I think. I think everything should be just about peachy. So we just have to do something like this. Pound define, declare, forward, declare, debug records, something like that, or forward, declare, debug records, like so. And we just make that a macro, which passes in the name. And all it does is it creates one of these by using the paste operator with whatever that predefined thing was in the build, right? So I'm just trying to get two of these, one for each translation unit that I've got, right? So I do declare debug records. I pass in, declare debug records. There we go. And now presumably that will just work, right? Then in here, if I want the debug record that properly corresponds to the one that I want, I know that all I have to do is take whatever the debug records are here, right? So something like access debug record, and it would be like an index, right? Something like that, I'm assuming, maybe, right? Then all I have to do is just do this, debug prefix found debug records, plus the index. Yeah? Oops. And that should give me the debug record. In fact, I could do it like that as well. So I just do debug record counter, and I'd be done. Yeah? What is the problem here? Index is an undeclared identifier. Oh, well, I should probably make that a pound define. All right. Debug prefix. Oh, the paste operator. Ah, right. This is that nasty thing. Oh, man. All right, this is going to make our lives a little bit harder. I take it back. I'm going to make this easier on myself. The way that the preprocessor paste operator works is really annoying, and it can't do the pasting with names because they don't get expanded beforehand unless they were a macro parameter and all this other nonsense, which is what's going on there. And there's some tricks you can do to make that happen, but I guess what I could do instead is just debug record array, right? Just do debug record array equals like debug records optimized. And here we could just do debug record array equals debug records main. I could just do that, and that way we don't have to deal with all this nonsense, right? Then there's no funny business there. I can just do something like, okay, debug record array, and it'll, the macro will sort of substitute that, and then we just say, okay, we pre-declare it, and then accessing it is just as simple as saying, I want to go ahead and grab the counterif 1, like so, and then at the end of Handmade and those guys, I don't really have to do anything else. I could just literally do that. You know what I mean? And furthermore, I guess this one, because they're in both, I could do something where I do debug record array. Where were those things that built that? Debug records. Like so. I can just pre-declare them both here because that's totally fine. There's no... I don't think there's any harm in doing that. Oh, no, that's not true. There is a little harm in doing that because if I do that, then it'll have a multiply defined symbol from the two compilation units. So we'll stick with what I had before. All right. So now, I think we've managed to skirt that entire problem. And we now actually are just getting the debug record array collapsing for free. Like, it was just done. And so now, all I have to do is just do that one write, and it's just writing to a known location, so it's not going to proliferate the amount of data or anything like that, and it's just going to be totally fine, right? I think it's literally just, that's it. So if we take a look at this, and we've got the line number and function name stuff, yeah, I think we just say, okay, there's the record. We do file name equals file name. We do record line number equals line number. We do record function name equals function name. We do record clocks, plus equals the RDTSC. And we'll actually have to do a little work there to make sure that's macroable, right? Actually, I guess it kind of works the other way. Subtract the RDTSC. And then when we come down here again, the only thing that we'd have to store here, I think, is we'd just have to store the counter value, right? So I think that would work. Yeah? So this is counter init. Counter equals counter init. And so then down here, all we would have to do is get that debug record back. And I guess technically we could just store the pointer to the debug record, actually, when I think about it. We don't actually need the counter init stuff. We'd just go like that. And then down here, we'd just say, okay, that record, the clocks, plus equals RDTSC. I think that just works. I'm kind of surprised. I never thought to do that before because counter was never available the first time I made, well, the first, second, third, and fourth times I made debug systems. So never thought of that, but I think that just works. I don't really know why it wouldn't. So let's just see if it did. What would we need to do to see if it did? Well, we've got printouts now, to some degree. So let's go ahead and just replace everything with this instead of what we were doing. Let's just full on say, okay, inside Handmade platform, you know what? Just vaporize all this stuff. It's gone, right? And we can get the hit count. We can put the hit count back in here if we want to too, right? Just keep that sorted like so. All we'd have to do for that is just, you know, ink the hit count every time. Now this is not thread safe or anything like that, so there's some things we might want to think about there as well. But, you know, one step at a time. Well, all right. So now that we've got that, if I just blow this stuff away, right, if we just say this stuff is gone, so goodbye, right, debug cycle counter is gone. Now when I come in here, we'll get rid of these counters, and we'll get rid of all this stuff, right? I guess here's an end time block counter thing, so that's one that we may want to support as well. How come begin time block didn't give me an error? Is it still defined? Begin time block. Okay, these are all still defined. So I'm going to also go ahead and just if these out for a minute, like so, so that all of those things will give errors. So I'm going to change this to timed block draw rectangle quickly. I'm going to change this to timed block process pixel. Get clamped rect area fill rect over 2. Is that actually known at here? It is. So what I'm going to do here is I'm going to do a timed block, and I'm going to pass that in with the count, because we can actually get that for free as well. Right? We'll just pass it in here. And all we have to do for that is just say, okay, the timed block stuff is going to take a number potentially. So when we do time block, and I guess, oh, and they don't even take a name, right? Like so. I think this will work. Don't quote me on that. Right, time block, I guess this doesn't have to do that either. We can do time block with the varargs, I believe. And then we can just do a paste on, like so that we'll get those extra parameters in here. And so then we can just have a default value, which is that the hit count actually plus equals some kind of a hit count that you pass in. By default, it will assume that you just want to count it once, but if you want to count that block many times, you can do that as well, right? So that's another way we can tackle that. All right, so timed block including handmade.h, that means that, oh, so does handmade.h not include handmade.h? It should have included handmade debug. Timed block is right there. Is it just because it doesn't have this? Wow, okay. Well, that's fine. Doesn't matter. No worries. Okay, so process pixel wants to be like this. Again, I'm just trying to maintain the feature set that we had because it seems fine, right? It's not onerous for us to do that. Time block underscore, oh, yeah. So this, not sure why it didn't like that. I guess because it won't expand this if it's part of the paste. I say. I would like to expand line, right? I would like line to be expanded so that I can just have one per line. I guess this is that same unfortunate problem. So I may have to do something like this where I call another layer down with like the number or something like that. I don't know how many times you have to do that. This is always really annoying to me. I hate this. The C++ preprocessor is like the worst thing ever. I mean, we can all admit that. But, you know, since it doesn't have the language features that you'd want for a lot of these things, you have no choice but to use it most of the time. But, so I probably will have to do something like this, where it gets translated through the macro multiple times. I feel like you need to do this twice, even 2 layers. There's this really weird stuff with the macro preprocessor. I think once doesn't even do it. So if you do this, it's still not enough. It has to actually go through 1 layer of translation, right? So we'll see, but you'll see what I mean in a second. I think that's what will happen. Yeah. Number ... Yeah. You can see that that doesn't actually fix it, right? It's still doing that. I'm gonna try it one more time, and then I may have to look this up. This is something I never remember, like ever. I never remember how to do it, but there are tricks. I've done them before. How is it done? How is it done? Oh. Whoops, that's not quite right. Yeah. So, I don't know, you can kind of see there some pretty ridiculous shenanigans. Hold on a second, let's see what's going on here. Time block, yeah. So, I hope you see what happened there. This is kind of just a vagaries of C++ preprocessor nonsense thing. There's no rhyme or reason to it, it's just how it happened to be written. So what happened was I wanted to use the line number, right, to expand on here. But unfortunately, if it sees the paste operator, which is something that sticks 2 things together, it actually just graphs on whatever the text was. And so I have to pass it through itself multiple times to make sure that the number gets expanded as a number, which it will in this line, so that it never, no entrance of the number of the use of the line macro plus the actual paste have to be separated by 1 whole round through the stupid preprocessor. Don't ask me why I even know that. This is just one of those things that, you know, if you program C++ long enough, you have to deal with. But hey, we finally got it, so it's fine. Again, nothing particularly special or great about that. That's just the way it goes. All right. So, we got a few more things left to deal with. We're not totally done yet, right? We're not totally at the end of everything that we might need to do. But we're close. So, overlay cycle counters. That would be what prints out the cycle counters for us. So we can go down here to the end, right? And we have debug record array. We just put it down below here so we know that it can access that, right? And now we can know that we could use our debug record array. We could use the array count of the debug record array, and that would actually print the thing out. Now, of course, we don't actually want to only do the 1 debug record array because we actually have multiple debug record arrays, but we'll deal with that a little bit further down the line. I guess it's actually debug records main, I think. Something like that, right? Yeah. So, what we want to do here, and there's some other, like I said, there's going to be some things but we're kind of running out of time, so I want to just kind of finish this up for the most part, and then we can look at it a little bit more. All right, so let's just finish up what we've got. We'll go ahead and put a timed block in there for game update and render as well. We'll just go ahead and put that like so. Inside our end time blocks, we no longer need them at all, right? Overlay cycle counters, we're going to have to forward declare because we're calling that after sort of the definition of these things. So that's fine, but we'll have to kind of do a little forward declaration up here. There we go. And in here, this is going to be debug record. And this is going to be that debug records main. Okay. So let's continue. Struct debug records optimized, not defined. Is that really true? I think it is. It's right there. So we just gotta put it in. I'm just option to debug records. Oops, nice. Gotta actually spell it the way I wanted it to. And then down in here, we've got the debug cycle counter printout in Win32. We're going to nuke that for now because I think we don't probably ever... We probably will nuke that for good, actually. But we'll leave it kind of left in for the immediate moment. All right, and now let's go ahead and run things and see where we're at, right? Hey, look. Look what we just got. Those are actually coming from our actual thing, I believe, right? Although no, actually, they're still probably using the wrong ones because I don't think we changed it quite yet, right? They're using this name table, but we don't need the name table anymore, right? So it's not quite hey look yet. We can just get rid of that, and in fact, I guess we can get rid of all this stuff, right? So what we want to do is go through each counter, and then instead of looking it up in the name table, which we don't actually need to do at all, anymore, we can just take a look at the counter and look at its file name. Cannot convert one from char to char star. Oh, my bad. Awesome. We probably want we're probably going to want a slightly smaller font for debugging. Just putting that out there. But man, that turns out to be pretty darn easy, actually. So now we need to sort of augment our ability to print things out. But now we actually have it such that we can put debug times throughout our entire code, and it's completely free. We don't have to do any work, really. The amount of effect on the code is almost zero, right? I mean, all it's doing is just this work right here. That's it. That's going to be pretty great. I mean, you can afford a lot of those, right? So, yeah. That's as good a place as any to stop, I suppose, because that is not the entirety of what we want to do with time blocks. We might want to do some call attribution with our timed blocks, for example. But, man, yeah, okay. I don't know why I never thought of that before, but that just totally worked. All right. Well, you learn something new every day. I'm going to go ahead and go to the Q&A. Yeah, like I said, that was what we wanted, and we kind of got it. So there's some more stuff we'd like to do, but I mean, pretty much that's what we wanted. And so tomorrow, what we'll be able to do is we'll be able to kind of go in here and work on our ability to print things out, so we can start to actually see the numbers, right? Because remember, we were kind of using we were using some library code to print that, and so we can go write our own text printout routines. They probably won't be great because we don't care; they're just for debug. But we should at least do them. All right. Well, if you have questions, now would be a good time to ask them. Go ahead and prefix them with Q:. So I'll see you. Let's see. Elsenoised says, there's an alternative way to start and the counter instead of using constructor-destructor pair. You don't have to store the data in the struct. Maybe not as convenient, but it's worth mentioning. I use it quite often when I have to begin X, write code, end X. It's basically a hacked, tweaked version of C#'s using statement. I think you'll find it interesting. Check out the small snippet if you please. What do you think? Well, let's find out. Let's see. Struct timed block. Pound define using for... Oh, interesting. well, I'm looking at this, and I suppose I should probably sort of show the way that it's being done here. So the way he's suggesting to do it is you can do a thing that's like pound define, using object data, and then he does a for loop, done equals obj, begin using data, oops, don't want to go beyond my own head, not done, done equals obj, end using data. So it makes like a for loop, right? And the for loop's exit condition is just going to be this not done here, and then it does the end at as the update step, right? So the thing I don't like about that is that introduces at least as many new variables into the function as this does, though. So I'm not sure there's really any benefit to it. In fact, I might say there's definitely no benefit to it. It's strictly adding more code to your code than this does, right? Yeah, so I don't know. I don't think I'm a fan. I haven't thought about it long enough, so maybe there's other reasons why I might like that, but that doesn't seem like a good win to me. That might just be me. James Widman, I feel like I missed something. Why does the array name need to be different between builds? So the reason the array name needs to be different between builds is because I want to print out both arrays. And so in here, I'm going to need, in like the next episode, right, when we do our actual printout of this data, I'm going to need to be able to access both of them. Now, they can't both be named the same thing, because if they were, I wouldn't be able to extern the other one and access it from here, right? So the reason I just made two different names, that seemed like the easiest way to make sure that that worked, you know? So that's all. That's the only reason. Twitch makes me itch ass. How do you move your typing cursor around so fast? Is that an IDE specific macro? Well, I have my Emacs set up to be like, if you hold down the control key, it moves by words. And if you, so control key plus the left and right arrows moves by words. Control key plus the up and down arrows moves to empty space. I just find those are easy ways to get around. And then similarly, I have like Alt J bound to like jump, so I can jump to a function or something like that. So I just have some shortcut keys that help me. They're not none of them are like super fancy. They're pretty basic, really. Could you expand on how you would have done the char star file name star function name with uints instead? Yeah, so what I was trying to say there when I was kind of bagging on how bad C++ is all the time, and of course, to be fair, you know, it's possible that they've added some features in the 8 billion features that they add every year, or every couple years, is I don't actually want a pointer to a file name. What I want the compiler to do is take all of the files that there are in the project, enumerate them from 0 to whatever the maximum number is, and then just have a table called file names that I can look up with a bracket. That way, if I want to store the file name, I can just store a U16 called file name index, which I know that the compiler, you know, that I can produce like this, like file name index, and it just gives me an index of the file name into that table. That would have been the way any sane person would have done this, right? But you know, sane people are in short supply. And SZ underscore, this is awesome. You have a few minutes left. Could you output the results or show them in the debugger? Yeah, I mean, we certainly can. Really, the thing is just we need to use a library to do it. That's the reason I wasn't doing it. So we want to go write ourselves. Like I said, we try not to use libraries on Handmade Hero so that I show how to write everything. But you could just use like one of the functions from the C standard library if you needed to. I don't know if we can get that in here exactly. I don't know what the consequences would be here of including, say, standard io.h, if that would work. Looks like it sort of does. So if we wanted to, we could go ahead and actually like let this happen. We could say, let's do this, right? and then we could have that printout, so that the text buffer that we prepare, right? So let's see. Cycle count is what? It's clocks. So I'll change that to cycle count. So that's really it, I think. And there you go. So that's the printout, and we're not resetting these yet, so they're just going to kind of go up ad infinitum. So if we wanted to reset them again, we'd need to do the stuff that was happening in here. So that is that is handle debug cycle counters. So we just need to kind of reset the stuff, and so we could do that as well here. I don't know that's where we really want to do that long term, but that's an example. And we could go ahead and make this, instead of the counter index, we could use the function name for that, right? And so yeah, does that help? Yeah. So I don't know why debug reset. That doesn't make much sense. Why is debug reset taking all of the time? Oh, we are actually timing debug reset, it turns out. So, yep, that's what that is. Game update and render. Well, game update and render. So we do have one problem with that, which is that game update and render, which is the other thing that we're timing, is actually not right. It's not blocking that. So in order to actually make that block, we would need to do something like this, right? We'd actually need to open a block for that, so that we know that it doesn't. We know that that gets closed. That block has to get closed before we would actually overlay the cycle counters, right? Which is, again, kind of annoying, because what we would, and this is something we need to address, so I'll just do it temporarily, but it's not what we would actually want to do, right? No, that's not gonna work. Yeah, we want to do this. We want to do this a little bit more tomorrow. There's a bunch of things that are kind of packed in there that we want to handle. But I guess I could do a couple more things just to show that it's working right. So I could put time block in here, for example, and that would be another one for that would be in there for debug update and render. So, right. So there's our actual timed one, and this one's just not right because the block is never closed. Does that make sense? So yeah, so we've got some stuff that we have to do, and basically what it boils down to is, because we are the renderer, we need a way of counting the amount of time spent in the renderer, but the renderer is the thing rendering the debug information. So what we want to do, like I said, we're kind of jumping the gun here but since you wanted to see it, we saw it, so that's good. It's fine. What we want to do is we want to postpone the information for one frame, so that on any given frame we're printing out the data from, say, the last frame, the previous frame, so that we can count the renderer properly, but still have the renderer render the debug information, right? Because it's sort of like a chicken and egg thing there. So we can't really, we got to be a little bit more specific about that. But that's not hard. It'll be easy enough for us to do, but we have to actually do it. Nico3695, do you recommend taking game programming as a major or programming in general? I don't know. I did not go to college, so I can't really help you out there. Elzen says, what other useful pre-proc values we could use other than file, function, and line? I don't know that there are very many other ones that are useful for this purpose. I mean, a counter, obviously, was the other one. but we used it. I don't really know that there's anything else that I can think of for debugging. The other stuff is usually for other reasons. But I could be forgetting one, or there could have been one added recently that I don't know about. Like I said, counter was actually added long after I'd written the previous iteration of my debug stuff. I haven't really touched it since then, and so I never really thought about the new things that it could add. So there might be some even newer ones that I don't know about, and maybe they'd be very useful. I don't know. I should probably go, take a spin through them and just see. I'm not really sure if I fully understand Unity builds. So Unity build is when we compile everything into a single file. I don't think that's the case because we do have multiple source files in HMH. Source files is not really the important part. It's how the compiler sees those source files when you pass it. And so in Handmade Hero, we really have 3 separate compilation units. And compilation unit is the right term to think about here because that's what the compiler actually sees. It doesn't matter how many files there are, right? Because you can imagine you have handmade.h, handmade.cpp. If handmade.cpp includes handmade.h and you only pass handmade.cpp to the compiler, well, there's only one compilation unit there. Because the compiler doesn't think about handmade.h as being a separate compile pass. It's just a separate file that gets stuffed into handmade.cpp before the compiler actually goes to work, right? And so what we do on Handmade Hero is we just pound include all our CPP files. So we actually only have 3 translation units. One that's the Win32 binding layer. And that's there so it can reload our code and we can do our loop live code editing stuff. So that's one. Thing 2 is our optimized code. And the only reason we have that is because the compiler is too dumb to let us say, hey, optimize this function. It has to be in a separate compilation unit for some reason. I have no idea why. And then number 3 is the rest of the code. And so we only have 3 of them, and that's why I say that we can kind of do stuff like this counter thing. Plain flavored, where did the whole weird I-interface C class style of programming I see everywhere come from? I don't know. I mean, COM, I remember, introduced that whole I-interface naming convention, I think, but I don't know if they made that up or if that was something they got from somewhere else, right? So I don't really know who started all that kind of stuff. Why do you have both U32 and uint32 type defs? What's the difference? There is no difference. It was just that I decided to switch recently. Like, even though I'm pretty old, I still change up my programming style fairly frequently, actually, to just make small modifications or whatever to it. And U32 and uint32, I started off the project using uint32 and I decided to go to U32. So really, eventually we'll probably just delete uint32 altogether and everything will just be U32. So that's more of a migration. They're no different. They're exactly the same. If exceptions are bad, then what is a good way to handle errors? Just return error codes? A global error value like an error no or get last error? What do you think of the idea of having a central error handling function that we call and pass it the error ID and it acts accordingly? So in general, I would say the right way to handle errors is to not have them. So that's thing 1, right? So a lot of times people will have more error handling than they should have because they allow errors. They allow things to be errors that shouldn't have been errors. So that's step 1. Step 2 is when you actually have legitimate errors that can actually happen in practice. You want to figure out where those come from, and you want to make those explicitly handled by the code path. So like, for example, one that we will probably do on Handmade Hero at some point will be if the asset file suddenly starts to not be readable, right? And if that happens, what we want to do is actually detect that case and set it up so that we then print out, a message on the screen that's like, hey, man, you need to figure out why the asset file just disappeared because you can't run the game without the asset file. But on the whole, there really shouldn't be a lot of error conditions, right? Error conditions, there's so few ways that you can really be in a legitimate error condition. Usually, it should just be part of the program. Like, the program itself should be written to consider the error condition as actually just a condition that it handles. Because if you didn't do that, then you don't really handle that error. at some level, right? Like either an error is actually a technical error that shouldn't ever happen in practice, or it isn't. And if it is, then you really only need assertions or things like that to handle it. But if it is a real error, then you need to handle it, and you need to write the code so that it does the thing the user would want done in that scenario, which makes it not an error at all. It makes it actually the way the program works. And so the answer to how to handle it is no different than how you would handle anything else. Hope that makes some sense. Why use record file name instead of record function name? I think we did end up using function name. I think that probably is an old question. Let's see. I'm kind of new to the stream. Is there a reason you hate C++ so much? Yes, there is a reason I hate C++ so much, and that is because I have to use it. So I like C. I think C is a pretty good language. I would really have liked the updates to C over the years to have been done by people who knew what they were doing. Because C was, is 1970s. I think C was actually made in like the late 60s even. So it's like really old. And it needed a bunch of updates to be able to do the things that we would want it to do for modern programming. And instead, what we got was C++, which has been routinely updated in ways that are absolutely ridiculous and pretty much useless. And so the reason I hate C++ instead of just ignoring C++ is it's the thing I have to work with, and it's really darn bad. And so I'm kind of mad at the people who constantly do really stupid stuff and leave me with a garbage language that I have to use, right? Whereas I'm not mad at the people who made Python because I don't know, maybe Python's a bad language, maybe it's not, but I don't have to use it. So I'm not going to hate on Python because I don't use Python, right? You can't really build up hate for something that you don't really interact with, because you're not constantly sitting there going, if only the people who made this language had a clue. I'm never saying that because I never have to use it. Will this compile with only the Visual Studio compiler, or will it work with GCC? It works with GCC. GCC is actually the place that introduced counter. The reason I was a little hesitant about counter and wasn't sure about it is because I couldn't remember if MSVC had added it. I thought they had, but I couldn't quite remember. GCC has like always had counter. I mean, it's not like they always had counter, but I'm pretty sure that GCC were the people who introduced counter originally. So I knew that they would have it. So LLVM, GCC, the code will work fine there. But I just wasn't sure about MSVC. Turns out MSVC added it. If you go back far enough, like MSVC 2005 or something, maybe might not have counter. I don't know. But obviously the later versions have it, so it's totally fine. Just to mention, it's a general programming question. Do you see the use of public variables being accessed outside the class bad practice versus using a getter accessor function? I would say that I don't even like the premise of the question in the first place. Getter accessor functions are almost completely useless and should never be written under any circumstances, in my opinion. I don't like the concept just fundamentally. I don't ever think that private is like just shouldn't even be used. So I don't even use classes. I just use struct so that everything is always public. And that, in my opinion, is the correct method. So there shouldn't be any getters, shouldn't be any accessors of any kind. The times that you add those is when something specific has to happen when that thing is accessed. And what people typically do, and I think this is a very, very bad programming practice, is they pre-game that. So they go, okay, I'm going to make a class called foo. It's got an int in it, which is like the data. But I don't want anyone to access the data directly, right? I want them to do this. So they wrote that instead of typing this. And everyone who uses it, who has one of these, now has to do, right? Every time. It's absurd. It's absolutely, completely absurd. I mean, look at all that typing. And now I want to increment this value. Well, instead of being able to just do this, right? Now I got to do this. It's insanity. All you're doing is spending your whole day typing for absolutely no reason. You get nothing for this. Zero. And the reason I say that is because the only thing you have to actually do, if on the odd, rare circumstance where you then need to add some kind of fancy business to accessing this stuff, is you just go like that. Now everywhere that access that code is going to be a compile error, and you can go ahead and change it to the accessor at that point. So never, ever, ever, ever put in an accessor until it actually does something. Not to mention the fact that everyone who wrote that code was not expecting it to do something. So they didn't test it that way. You don't know if it's a performance bottleneck, right? Someone might be thinking they're just incrementing a variable and that's free, but it turns out now you added like a hash table lookup in there, and all of a sudden the performance goes to crap, right? So never, ever, 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 under any circumstances, do this thing. This is like awful code. Just absolutely horrific. This is like you're fired, right? Like I fire you immediately if I see anything like this. Never, ever. If there is an accessor, it had better do something in there. Day one. Full stop. And that is all I have to say about that. Insofar as, how would you handle parsing errors or exceptions in a recursive descent parser? That's a little bit of a big question. You'll have to hold that one till when I do Handmade parser. Waterly Mun. Internet says counter started on VC++. Oh, really? Huh. Is that true? I had no idea. Because I just thought it was on GCC. That's where I first heard of it. And I didn't think that you could do it on MSVC. But if it started on MSVC, then that's also cool. I mean, we're looking at the predefined macro specs for GCC, so obviously it's on GCC. And if MSVC was the first one to have it, then yeah, I mean, I think we're totally golden on that. I think that's it for questions. Looks like that's it. All right, we'll spin it down, peoples. We will spin it down. Well, that was a pretty entertaining stream today. And that is probably going to be something that I go put into the Molly Rocket code base now that I know that that's that simple. I just never thought of counter before for some reason, and that's why rewriting code is good sometimes too. I mean, like I write something and I reuse it, and then I forget, the limitations under which I wrote it, and then I come back and look at it again, and it's like, oh, well, why am I doing it that way? There's a way smarter way to do it that I just didn't know about, or that wasn't available, or I hadn't thought it through at the time. Who knows why? And there you go. Imagine that. Anyway, thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with this code at home, you can always pre-order Handmade Hero, the game, on handmadehero.org, and you get the source code as we're working on it. So it's kind of available from day one, just as we go. Every night I upload the source code so you can download it and play with it yourself, and experiment and kind of like reinforce anything that you may have learned watching the stream. So I highly recommend that. It's a good way to go if you're trying to learn from the series. I also highly recommend checking out some of the other stuff we've got here. There's a forum site you can go to ask questions. You can go get community ports to Mac and Linux that people have been working on. You can get an annotated episode guide people have been working on. You can also go to our Patreon page if you want to support the video series. And I've got some exciting things to talk about coming up with the Patreon a little bit later as well. We have a tweet bot which tweets the schedule at you. And that is kind of handy if you're trying to catch the stream live. So yeah, check that out. If you want to come back tomorrow, 5 p.m. Pacific Daylight Time is the next time we'll be streaming. But if you ever don't know, and you just like, I want to see the next Handmade Hero, that tweet bot will always tell you, and so you can kind of figure out if it's going to be a time that works for you. Anyway, Tomorrow we'll go start cleaning up our printout ability there, because now we've got some debug counters. We'd like to be able to see them. And so now would be a time for us to start maybe doing a little work on the actual debug overlay stuff, because again, that's a very crucial part of our debug system. And now that we've got something we actually want to see, it would be a great time for us to go start working on that and making a nice little thing that we can use that actually is, kind of a good sort of debug overlay that we can actually manipulate and do interesting things with. So that's what we'll start doing tomorrow. Until then, I hope everyone has fun programming, and I will see you guys on the internet. Take it easy, everyone.